Okay, so today's lesson is about similar triangles, so make sure you have your notes out. We are going to cover this geometry standard of understanding the concept of similar triangles. We're going to be able to identify similar triangles and use indirect measure to find the missing measurement. Okay, so in your notes, you should have your notebooks out. Go ahead and copy this definition and the examples. Make sure you get it all copied down. We're going to pause the video so that you can get that copied, and we'll start again when you're ready. Okay, so hopefully you guys can hear me over the drums in the background. If it gets loud, I'll try and pause. So the idea is that when you have two angles in one triangle that are congruent, and remember congruent, we write it like this, and it means same, to two angles in another triangle, that means that the third angle is also going to be congruent and the triangles are similar. That doesn't mean they are the same. That means they are similar. It means they have similar angles. They may not be the same size, but they are similar. Okay? So similar triangles, I'm going to write this down. I want you to copy it down. Similar triangles have two matching pairs. That's an I. Of angles. Two matching pairs of angles. Therefore, the third angle is also matching. Go ahead and add this to your notes. We'll pause the recording here so that you can copy this down and then continue when you're ready. Okay, so moving on. So here I have two triangles. I want to look to see if I have two angles that measure the same. If I notice this one is angle measures 50, and then so does this one. So these two are congruent angles. My next angle measures 75. So I'm going to look to see over here if I have one, and I do. Look, this one also measures 75. So based on my information, these two angles, X is going to be the same as Y. Based on what we just learned, X is going to measure the same thing that Y does. So let's see if we can figure this out. So again, let's repeat what we know about the sum of interior angles. Okay, the rule is, so the sum of interior angles in a triangle will always equal, anybody know? They will always equal 180 degrees. Okay, make sure you get this copied down. So based on this rule, okay, this little thing that we've proven and we've already worked on, I'm going to add my three angles together. And I'm going to equal 180 degrees. So the first thing I need to do is add 75 and 50 because they're like terms. When I add 75 and 50, I get 125. And now I have plus X is equal to, and I'm going to bring down my little bar there. So now I want X all by itself. So this is a positive 125. So to move this and eliminate X on this side, I have to add the opposite. So the opposite of a positive 125 is a negative 125. This becomes 0. 0 is a non-number. I don't need to write it. So x is going to be equal to the difference between 180 and 125, and that's 55 degrees. So let's check it, because we can do that same thing here. Okay, if x is equal to 55, then the theory says that y is also going to be at 55. So we're going to do it again. 75 plus 50 plus y this time is still going to equal 180 degrees. So 75 plus 50, that gives me 125 plus y is equal to 180. I'm going to add the opposite, so I'm going to subtract 125 from both sides. So y is going to equal 55. So is y equal to x? They're both 55 degrees. So yes, that is true. So that means that I can say about these two triangles that since they have two matching triangles, the third are also going to be matching, and these triangles are similar. The triangles are similar because they have two matching angles. Make sure you have that written down, and then we'll move on in a sec. Alright, so hopefully you have all that written down. Let's move on to the next one. So let's see, are these similar or not similar? What do I need to look for? I need to make sure that I have two matching angles. So this one here is 63, and we'll take this one as 63. So that works, yes. How about 54? Do I have a match over here? I don't. So that means that I'm going to have to actually do some work here. And I can pick one or the other. It doesn't matter which triangle you pick. I'm going to take this one over here. I'm going to say 54 plus 63 plus x is going to equal 180 degrees. Okay, so I'm going to take my two common or like terms and add them up. 54 plus 63 is going to equal 117. So if you have your calculator handy, that would be good, because I don't mind if you use it. I use my calculator today. You should too. So to move my 117, I have to add the opposite. So the opposite of 117 is negative 117. So I'm going to subtract 117 from both sides. This becomes 0. Bring down my x and my equal. The difference between 180 and 17 is going to be 63. So that tells me that this angle here is going to be 63 degrees. And look, I have a match. So that means since I have two matching triangles or angles, the third one is also going to be matching. So y is going to measure 54. So I'm going to say the triangles are similar. Let's abbreviate triangle. Why? Because why? I'm hoping you said they have two matching angles. So if I'm asking you to tell me if they're similar and explain, I want to make sure that you have this complete sentence written down. Okay? Go ahead and make sure you have it copied down and push play when you're ready. We'll pause right here. Okay, so let's move on to the next slide. Almost done here. This is a lot of information, but you guys can do it. So this would be the same, right? So I know that this is 90 And I know that this is 90 because they are marked by my box or my square, which tells me it's a right angle. So I have 90 and 90, so that's my first congruency. I don't have my second one. This is 42 and 38. So I can pick one or the other, doesn't matter which one, and solve for x or y, and then I will be able to know if they're congruent or not. So I'm going to set the problem up, and you guys are going to solve it. So I'm going to take 90 plus 42 plus x, and it's going to equal 180. Go ahead and solve it. We're going to push pause. You guys are going to solve it, and then when we come back, you can check your answer. So push pause. Look at that. My answer magically appeared. So it tells me that x is equal to 48. So I have 90, and then I have 42 and 48. I have 90, I have 38, and y. So are these triangles going to be similar? These are not similar. Okay, so here's your alternative, right? If they are similar, then they're similar. But these triangles are not similar because they don't have two matching angles. And voila. Make sure you copy down the answer, and we're going to move on to some tricky stuff. Okay, so we're going to skip these two, but they're the same concept, so you want to make sure that you have your two matching angles, and if you have two matching angles, then you can tell me if they're similar or not similar. Pick one, add them up, solve for x or y. We're going to look at something new, but it's very similar, so we want to look at the sides this time. Okay, so this time we're going to look at them as a proportion. So I'm going to look at top and bottom triangles. Here I have 4 and I have x, I have 10 and I have 5. So I'm going to write them up as a proportion, and I need to make sure that I write them up the same way. So I'm going to take my big number over my small number. So I'm going to say 10 over 4. And is it proportionate to this one here? So my big number is 5 over x. And I'm going to solve this proportion problem by doing some cross multiplication. So I want to multiply my x first so I can have my variable on the left. So 10 times x is 10x. 4 times 5 is 20. And then I'm going to solve for x by dividing both sides by that 10. This becomes 1. 1 is shy. So we're going to go ahead and cross up them zeros. So 2 divided by 1. 1 goes into 2 twice. X is equal to 2. Since it works beautifully, these are similar triangles. Okay, so they work out proportionally. So let's look at this one here. Okay, so now I have 12 and my diagonal is x. I have 9 and my diagonal is 12. So I'm going to write up that proportion as, again, I'm going to take my big over my small. So I know that 12 is my diagonal, 9 is not. Over here, x is my diagonal, and 12 is my side. I'm going to do my cross multiplication. I'm going to say 9x is equal to 12 times 12, which is 144. And I'm going to divide both sides by 9. This is going to become x is equal to the quotient of 144 divided by 9. And this is when a calculator comes in really handy. But if you don't have a calculator handy, you can still do it old school. 9 goes into 14 once. Subtract 9. Bring down your 4. 9 goes into 54 6 times. 9 times 6 is 54. That gives me a really cute little answer of 16. You may have some like this next one on your homework, so make sure you have this copied down. These are great notes. Here's an example of a real-life use of this application on the next frame. Go ahead and pause if you need to, and we'll continue in 3 seconds. All right, so here I have two. Are they similar? Are they not similar? Okay, so we're going to find this missing distance here. Okay, so we have some bridge builders and they want to build a bridge, but they drew similar triangles to find this distance. This is a right triangle, this is a right triangle. So I have 60 feet and 50 feet. And then over here, I have x feet over 40 feet. So I'm going to write my triangle up. So I'm going to say 60 over 50. Now, how do I know which is which over here? Because they're kind of twisted, right? Well, I want to look at the position, okay? So if I'm looking at this triangle here, I go 60 square 50, or right angle 50. So here, I would go x square. Okay, hold on. So I'm going to go square 50c. So here would be square 40c. So my 40 is going to be on the bottom, right? Square or right angle 50c, right angle 40c. So I'm going in the same direction. So my x is going to be on the top, my 40 is going to be on the bottom, and I'm just going to cross multiply to get my answer here. 50x is going to be equal to 60 times 40. Easy way to do that is say 6 times 4 is 24, and then add my 2 zeros. Then I'm going to go ahead and divide both sides by 50. I'm going to cross off my last zeros there. And so this is going to give me x is equal to 5 goes into 240. I don't know. So let's go ahead and do my old school division here. 5 goes into 24 4 times. That's 20. Bring down my 4, right? Because I subtract. Bring down my 0. 5 goes into 48 times. That gives me a 0. So x is going to be equal to 48 feet. Okay? We're going to do one more because I know you have a problem like that in homework. Make sure you have this copied down. Pause it now if you need to. Push play when you're ready. Okay, here we go. Work with a partner to, okay. You don't have to work with a partner. We're just going to look at these little pictures here. Okay, so we want to see if these guys are similar, okay? So we know that this boy is 5 feet and the sun is coming down this way, and here's his shadow, and there is 3 feet here. So what is the sun's ray? Here we have a flagpole that's X feet tall, and the shadow it casts is 36 feet long. So how tall is that flagpole? So I'm going to go ahead and use my same method here that I used, right, for the last two to figure this out. So I'm going to say 5 feet over 3 feet. So the height over the shadow. Here the height is x. I don't know what the height is, but the shadow is 36. And then I'm going to do my cross multiplying. So I'm going to get 3x is equal to 5 times 36. And that's going to be 180, right? Because 5 times 3 is 15. That's 150. 6 times 5 is 30. That's 30. And then we're going to go ahead and we're going to divide both sides by 3 to get x all by itself. And that's going to tell me the height of my flagpole. So I'm going to take 180 and I'm going to divide it by 3. 3 goes into 18. 6 times. Gives me a 0, bring down a 0. Make sure I bring my 0 up. So x is equal to 60 feet. The flagpole is 60 feet tall. Alright, so that's kind of cool, and this is a real world application of this particular standard. So hopefully you got some really good notes. Pause it here if you need to. This is the last slide of the video. See you guys tomorrow.